guy, I call him Nigel 5. Nigel is acting up a little today, so sometime during my presentation I want to see if I can very quickly try and figure out why he's being a little child. My name is Solomon Benge King. King is my real name. Everyone keeps asking me. It's my real name. He has already given the introductions. I like to call myself a digital adventurer. I like anything digital. So whether I'm on the computer, I'm doing digital art. Whether I'm in a lab, I'm doing digital electronics. Whatever it is that I'm doing, whether I'm doing photography, I prefer digital cameras. I like the digital world. Today we're going to talk about robotic science. And I normally prefer, those of you who have attended the cafe size that I've spoken at, I prefer interactive sessions. So unfortunately, we don't have much time, so it may not be that interactive, but I normally prefer to engage people I'm speaking with. First of all, we all know what robots are, right? We have an idea. Who can volunteer some ideas? What is a robot? What do you understand? Like someone say, don't be afraid of giving the wrong answer.
A robot is a machine designed to perform a particular task.
A machine designed to perform a particular task?
I think a robot is a machine that operates automatically or on a remote control.
Okay, operates automatically or remote control, yes.
According to my research, it's a mechanical device that operates automatically. It actually does things that human beings wouldn't like to do.
Okay, very good. One last one, yes.
I think
Okay, there is one that concept in there, but the more answer that is machine. Right? Now, there are very different robots. It depends on who you ask. If you ask a direct definition of a robot, it's transformers. If you ask a company, his definition of a robot is a static thing that the core essence differentiates a robot from a machine is that it has what you call a brain. Right? And brain, which I'm going to try to perceive it. What's annotated by us humans that to sort of make creatures. People create robot looking at them. Essentially, we're trying to replicate life, right? In a small measure of intelligence. It's very hard to create intelligence, but you can create the components that that support this intelligence. Now, if we look at that as a basis for the definition of a robot, right? We're going to look at a robot as a machine that is intelligent, sort of, that has a brain, that is programmable, that is run by a computer, and we're going to look at it in the context of a machine that is sort of human, right? They prefer to call them humanoid robots because they look like humans. There are about 5 core physical aspects of the human body that roboticists try to imitate, right? If you look at the human body, one of the things it has is a structure, right? Your skeleton, the thing that supports you, that holds you together physically, is your skeletal structure. You have a muscle system that allows you to move these bones that the skeleton supports, right? So now you notice that we are now moving from the lowest level of support and we're beginning to add structural and functional details to that element. You have a sensory system, the nerves, the central nervous system. You know, you can touch, you can smell, you can see, you can taste, you can hear, right? And you have a power system. The power system for any biological creature is food, but the body converts this power into usable energy that allows the muscles to move the system, that allows your brain to work, that allows your body to react to the environment around you. And lastly, and most importantly, it has your body has a brain. It has an intelligent system. Now, intelligence is different, is a little tricky to describe. Many people confuse intelligence with self-awareness. Intelligence is the ability to sort of intelligently interact with the environment around you. There are things that the human body has that you cannot replicate. Things like a soul, things like morality, things like differences between right and wrong. These are things that are part of your cultural upbringing, that are part of your growth process, that are very hard to replicate in a robot system. There are scientists who are trying to create artificial brains using a series of, have we all heard of transistors? Yes. Yeah, electricity. There are people that are trying to replicate an elementary human brain using the principle of neurons, right? You know the brain is made out of lots of neurons. So that if you look at one single neuron, there are people who are trying to replicate that in the digital world using transistors. But we're not going to do details. Examples. You can give me examples. Need 5 examples of robots. Anyone? Anyone? Yes.
There is one from HR that's been made by Japan.
Okay, that's a real life one. We're talking about in movies, you know, those really fancy, complex robots. Yeah. Terminator. Which one? What's the big or the other one? Yes. You had it Terminator. Yes.
In the movie in Star Wars, there is this robot called R2. It's for protection, as in it senses danger and everything.
Great.
There is the military robots that they take them to the battlefront to fight.
Yeah. R2D2 and military robots. You at the back.
We have the Autobots, which are Autobots.
Autobots, yes.
The Transformers.
The Transformers. Last year, go.
Robocop.
Robocop. Robocop is technically not a robot.
Famous.
Robocop is not a robot because the brain is human. So they call them cyborgs. Yes, they call them cyborgs. So it's a mixture of machine and a small element of the human or an animal. There's a cat that was recently given an artificial leg and it actually uses it to move. Other examples are WALL-E. You guys have watched WALL-E, you know, the famous Disney movie. And then an older one called Johnny 5. There was a very old movie called Short Circuit, back when some of us were still young. It's called Short Circuit, it's called Johnny 5, and it looks kind of like it. I will show you the pictures later. Real world robots. You mentioned one, J what? HRP4. Any other robots? Yes? Huh? Robot. Oh, Roomba. Roomba is a robot that sort of vacuums the house automatically. Yes? Anyone else? Cyber? Cyber9. What does that do? Cyber?
The surgery.
Oh, okay. It's a surgical robot. Okay, cool. Yes? Okay. There are a couple of robots that Sony made a robot dog called Aibo that was very popular, but they discontinued it. Honda has made a robot called Asimo that is humanoid. It can walk, very slowly, but it can walk. And then NASA has what they call Mars rovers. Mars rovers are like, they look like tiny toy cars, but they are very complicated pieces of equipment worth millions of dollars. And then the industrial robots, the ones that you find in car assembly lines, they're doing automated processes. And then there's a more recent one that was called, it's just a hand. It tries to imitate the human hand. Very complex. It's worth about $3-something million. It's just a hand. I'll just show you a few pictures of some of the few that we've discussed. I don't know if you can all see. It's a good thing my laptop is one of those crazy big ones. This is the Mars rover. Can we all see? All right, this is the Mars rover. This NASA sends some of these to the moon, some of them go to Mars, and they're fully autonomous. They go around collecting data, spectrometry, analyzing radio waves in space, collecting soil samples, and then they transmit this data back to Earth. This is a real life one. This is an example of an industrial robot. These are the ones you find in manufacturing plants. It's stable here, and it has a mobile platform. So all it does, it moves from place to place, doing extremely repetitive tasks. The next one is, someone mentioned it, C-3PO from Star Wars. Sorry, this is R2-D2, sorry, from Star Wars. It's a fictional robot. This is its friend, they always like together. This is called C-3PO. Can we all see? All right. This is Aibo, the robot dog that I was telling you about. Very popular with kids and adults because you could program it to do crazy things and it would actually sort of grow. You know, it comes to you as it's this size, but it's mentally a puppy, and as you teach it, it becomes a little more mature and This is Aibo. Let me just go back. This is C-3PO, fictional. This is R2-D2, fictional as well. This is the industrial robot found in manufacturing plants. And this is the Mars rover that goes to Mars. Right. And then this is the hand that I was telling you about. Very complex piece of equipment. And then this is Honda's Asimo. Asimo is the one that kind of walks around. Right. Now, the difference between, like I mentioned earlier, the difference between robots and normal machines like your cell phone is that robots are programmable, right? Now, just because it doesn't walk or move doesn't mean it's not a robot, right? If we have already defined it as a machine that is reprogrammable to do specific tasks. So like the industrial robot, it doesn't move, it doesn't leave the premises, but you know, it's a robot. It's an automated process with a level of control, right? So if we look at the human body that we described earlier, right? If you look at a robot like Asimo, it's sort of human, right? It looks like a human. Of course, once you open it up, but people try to mimic the human body. If we go back to our analysis of the physical components of the human body, you have the structure, right? Most robots are made of a certain material and a certain structure. For example, if a robot needs to move, how does it move? It can either use wheels, it can use legs, it can have one leg, two legs, there's some that just go. Then there's some that have 6 legs, some that have 4 legs, then you have a muscle system. Most robots move through the means of something called an actuator. Actuator is anything that translates movement. Right? So like a hydraulic machine, that hydraulics